When the EXA-Mars Trace Gas Orbiter captured the first clear images of 3I/ATLS from Mars, it marked a turning point in our understanding of interstellar visitors. The object hurtling through space at thousands of kilometers per hour wasn't just visible, it was active. A faint halo of gas and dust surrounded it, but there was no tail, defying expectations for any comet this close to solar influence. The European Space Agency's success in photographing the coma was a technical feat in itself, achieved despite the object's faintness and relentless speed. If you're still watching, subscribe now. You crave more than answers. You seek what lies beyond. Subscribe now and be part of the few who never stop searching. Meanwhile, NASA's Perseverance rover captured a luminous streak later revealed to be motion blur, a reminder of how easily even cutting-edge equipment can mislead when dealing with cosmic anomalies. And while the Mars Reconnaissance Orbiter's high-resolution data was delayed by a government shutdown, the early images had already triggered intense debate. Was this a comet, a fragment from another system, or something engineered? The object's behavior didn't answer questions. It raised more. What 3I/ATLS has shown us isn't just the power of modern space observation, but the scale of what we still don't understand. Its brightness, density, and lack of a tail challenge known models of cometary behavior. Its path, interstellar, stable, and remarkably aligned, has forced scientists to consider origins beyond the norm. And theories suggesting such objects could act as planetary seeds only broaden the implications. Whether it's a relic from a distant star system or something more radical, 3I/ATLS is proof that interstellar objects aren't just fleeting dots in the sky. They're messengers, carriers of chemical, physical, and perhaps even technological secrets from other worlds. The images from Mars didn't just document a phenomenon, they opened a door, and what lies behind it could redefine how we see our place in the universe. For the first time in human history, an interstellar object was imaged clearly, not from Earth but from Mars. In October 2025, two spacecraft operated by the European Space Agency, Mars Express and the EXA-Mars Trace Gas Orbiter, captured the clearest images ever taken of 3I/ATLS. A visitor from beyond our solar system, hurtling through space at speeds that defy easy tracking, was caught within the lenses of orbiters designed for atmospheric research and Martian mapping. The feat wasn't easy. The object was 30 million kilometers from Mars, faint, fast-moving, barely distinguishable from the background noise of stars and cosmic haze. But ESA's engineers pushed the limits of their systems. Using long exposures on the EXA-Mars orbiter's Cassis camera and stacking dozens of shorter shots on Mars Express, they made the object visible. What they saw wasn't just a point of light, it was active. 3I/ATLS was venting gas. It had a visible coma, a glowing halo of dust and vapor, proof that it wasn't inert. After traveling who knows how many light-years through interstellar space, it was still alive in astronomical terms, shedding material, reacting to the proximity of our star. But what it didn't have was just as revealing. No tail. Typical comets, when they begin to heat up, grow long tails of gas and dust pushed outward by the sun's radiation and solar wind. Not this one. The coma was there, but the tail was absent. Theories began to form immediately. Some suggested this was simply the earliest stage of activity, that given more time, it would develop the familiar tail. Others proposed the outgassing mechanics were different altogether, or that the orientation of the release made the tail invisible from our angle. Either way, the missing tail only deepened the mystery. NASA's Perseverance rover tried to contribute. Positioned on the Martian surface, it pointed its navigation cameras skyward. What it caught was confusing, a bright streak across the sky. Some thought it was the object itself. The images circulated widely, but the truth was more technical. The streak was caused by motion blur, stacked exposures of a faint object that moved faster than the rover's cameras were designed to track. Misleading. Not a hoax, just another example of how challenging deep space imaging really is. Meanwhile, Mars Reconnaissance Orbiter held the best potential for a breakthrough. Its high-resolution imaging science experiment HIRI's camera could offer unmatched clarity, but as the object passed close by, the data pipeline went quiet. A government shutdown in the United States delayed the download and processing of that critical data. The instruments were still running. The images were still taken, but the transmission stopped. That silence was deafening. Amid the delays and confusion, speculation surged. People questioned the nature of 3I/ATLS. Was it really a comet? Or was it something else? A probe, a relic, an engineered object sent from another system? That debate wasn't new. It had trailed the object ever since its discovery. But the new data only added fuel. The object was brighter than models predicted based on its estimated size. Its trajectory was unusual, aligned in ways that natural objects from interstellar space usually aren't. And then there was the activity venting without a tail, consistent with sublimation, but at levels that didn't quite fit the standard behavior of solar system comets. Still, the mainstream consensus held firm. This was natural. Atypical, yes, but not artificial. The evidence wasn't strong enough to suggest anything beyond an odd interstellar comet. Yet even within that framework, 3I/ATLS was stretching definitions to the breaking point. Its acceleration didn't match gravitational expectations. Small deviations were detected, non-gravitational accelerations that hinted at internal processes. Not engines, not steering, just the force of gas escaping from within. That alone wasn't strange. Other comets exhibit similar behavior, but the mass of 3I/ATLS raised questions. Analysis pointed to a dense body, 5 kilometers in diameter, over 33 billion tons. That's not a loose collection of icy debris. It's solid, heavy, stable, and for something that size to be accelerating in any measurable way due to outgassing, that outgassing has to be substantial. Which brings us back to the question, where's the tail? Its lack of a visible tail despite clear signs of sublimation challenged the visual assumptions of comet behavior. And when a body this large, this massive, appears active without displaying the usual signatures, the usual categories start to fall apart. That's when a different kind of theory emerged. What if objects like 3I/ATLS aren't just travelers? What if they're seeds? Some astrophysicists proposed a new role for interstellar objects in the life cycle of planetary systems. Instead of just being ejected debris from chaotic star formation, these massive stable fragments could act as catalysts. Planetary cores, protoplanets in transit, preformed building blocks flung into young stellar systems, where they could act as gravitational anchors or chemical sources. In that theory, 3I/ATLS wasn't just a passive observer of the solar system, it was participating in a galactic process. Planet formation, cosmic exchange, system seeding. Not by intent, but by nature. These objects might carry the ingredients for new worlds, spreading them across light years, embedding them in the dusty rings of future stars. That's not science fiction. It's a working theory, and this object might be the first real test of it. What's clear is that 3I/ATLS has shattered expectations about what an interstellar object can be. It is massive, active, and non-standard. Its brightness doesn't line up with basic reflection models. Its movement, while natural, carries anomalies. And its behavior under solar influence defies simple categorization. The ability to detect it early was a turning point. Unlike Oumuamua Morris off previous interstellar visitors, 3I/ATLS was tracked well in advance of its closest approach. That meant real-time, coordinated observation was possible. And despite the challenges, distance, motion, faintness, and political delays, data was gathered. High-quality images were captured, and the global scientific community was able to observe the object not as a brief streak on its way out, but as a living body interacting with the solar system. That's a milestone. It means that next time, we'll be even better prepared. Instruments can be retasked, missions can be launched, protocols can be developed for intercepts, close-range studies, maybe even sample returns. Because the next interstellar object may pass closer, or slower, or carry even more dramatic properties. And that's the broader implication of 3I/ATLS. It's not just about this one object, it's about what it means for the future. The technology used to image it from Mars proves that we're reaching the edge of a new capability. Real-time, deep space observation of visitors from beyond. The chance to study, not guess. To measure, not theorize blindly. These aren't just icy fragments. They're messengers, natural archives of ancient systems, pieces of planetary histories we'll never see, and every one of them is a data point in a galaxy we're only beginning to understand. The more we look, the more we'll find. 3I/ATLS may never tell us where it came from. It may never answer the questions that have followed it since detection. But what it's already revealed is enough. It's shown us how complex, dynamic, and interconnected our universe really is. It's proven that deep space is not empty. It's alive with motion, matter, and meaning, and it's reminded us that we are not isolated. Not as a solar system, not as a species, we are part of a greater exchange. Material is moving, worlds are forming, histories are colliding, and we are watching. Stay informed, stay curious, because the story of 3I/ATLS isn't over. The data is still coming. The analysis is ongoing, and the implications, both scientific and philosophical, are only beginning to take shape. Subscribe now for more updates, because the next interstellar visitor is coming, and this time, we might be ready to meet it. The moment 3I/ATLS came into view from Mars was more than just a technical achievement, it was a turning point. A milestone not just in space imaging, but in how humanity observes the cosmos. For the first time, we saw an interstellar object not from afar, not as a fading trace after it had already passed, but up close, in real time, as it interacted with our solar system. And it wasn't just one image. It was multiple, taken by separate spacecraft. Stacked, verified, compared. The EXA-Mars Trace Gas Orbiter, Mars Express. Perseverance. Mars Reconnaissance Orbiter. Every instrument available was turned toward the void, chasing the same faint object, moving at tens of kilometers per second. The sheer coordination behind that effort, across space agencies, across instruments, across continents, was staggering. But the most important detail wasn't the images, it was what they showed. A coma. Not theoretical. Not inferred, visible, real. A halo of gas and dust surrounding the object, signaling activity right there, in the open. That coma confirmed that 3I/ATLS was releasing material, responding to the sun's energy after untold years or centuries of interstellar drift. Still, no tail, no dramatic plume streaking into space, just the halo, diffuse, faint, controlled. That's not how it's supposed to look. If this were a standard comet, the heating from the sun would have sent gas and dust streaming off its surface, forming that long signature tail, but that's not what we got. We got behavior with no precedent. And the lack of a tail wasn't just cosmetic, it was fundamental. It raised the question, what's really happening here? Some proposed it was a matter of orientation, that perhaps the angle between the sun, the object, and the observers simply hid the tail from view. Others argued it might be due to the composition outgassing substances that don't produce much visible dust, or emit in wavelengths beyond standard optical range. But none of those explanations were confirmed. None of them had the data to close the case. Then came the data delays. The most powerful eye in orbit around Mars, Interstellar, had snapped its set of high-resolution images. These were the frames everyone was waiting for. The ones that could show surface structure, reveal rotation, possibly even hint at surface irregularities. But the transmission stopped cold. A government shutdown in the United States disrupted the download schedule. The instruments were operating, the images existed, but the pipeline was frozen. Access was cut off. And with that, the vacuum opened again. Into that silence came speculation. Was it just bureaucratic bad timing, or something else? Were the images too sensitive? Did they show something unexpected, something that required more than the standard review process? These weren't fringe questions, they were asked by serious observers, because this wasn't just any object. It was the third interstellar visitor we'd ever observed. And the first one caught this clearly. The silence from NASA only fed the fire. No updates. No briefings, just waiting. And then the images from Perseverance stirred up the next controversy. A streak of light across the sky. Bright. Suspicious. For a moment the community held its breath. Could the rover from the surface of Mars have captured a direct visual of 3I/ATLS? Would the object's form be visible? But the excitement died quickly. It was motion blur. A misinterpretation caused by the camera's limitations. The rover's navigation cameras weren't built for astrophotography. The streak wasn't the object itself, it was the artifact of time-lapse exposure on a fast-moving target. A reminder that even the most advanced tools have limits, that in deep space observation, precision is everything, and one flaw can cloud the truth. Still, the real story remained a non-native object, originating from another star system, observed up close as it interacted with our solar system. The debate over its nature raged on. Artificial or natural? That question had lingered since its discovery. The object's clean trajectory, its brightness, its activity without detail, all of it fed theories of artificial origin. That maybe it wasn't a comet at all. Maybe it was a probe. A relic. Something built, not born. But the consensus among scientists still leaned toward natural. A typical, yes. But natural, a comet-like body ejected from a distant planetary system. A survivor of cosmic chaos. A fragment from a world we'll never see, flung into the void by forces as old as the stars. And yet, even within that explanation, nothing about 3I/ATLS was ordinary. Its mass, estimated at over 33 billion tons. Its size roughly 5 kilometers across. Not a loose snowball of ice and rock like most comets, but a dense, stable object. Compact. Solid. Able to retain shape and coherence across immense distances and temperatures. Its activity pattern was wrong for its mass. If it was accelerating from outgassing, as the data suggested, the amount of material being expelled had to be significant. That's fine for smaller objects. But for something this massive, that level of non-gravitational acceleration shouldn't happen. Unless internal pressures were high. Unless something else was at work. It led researchers to look deeper. And that's where a different theory began to emerge. Less exotic, but no less profound. What if interstellar objects like 3I/ATLS weren't just drifting leftovers? What if they served a purpose? Not because someone designed them, but because of what they represented. The seed theory. The idea that massive interstellar bodies like this could act as planetary starters. Preformed cores ejected during the violent early stages of star system formation. Material already clumped together, already partially processed, ready to act as the scaffolding for new worlds. If these objects reached young systems, systems still forming planets, they could become the nucleus of new planets. Not random visitors, but agents of creation. Not passive but active in the evolutionary process of galaxies. That theory flipped the entire conversation. Because now 3I/ATLS wasn't just a subject of curiosity, it was part of the cosmic engine. Not a threat. Not a messenger. A builder, a traveler carrying the raw ingredients of planet formation across interstellar space. And if that theory holds, then these objects aren't rare. They're common. Necessary. Fundamental. It changes how we see the universe, and how we see our own origins. Because if 3I/ATLS could carry the seeds of planets, what else could it carry? Water, carbon, organic molecules. It opens the door to panspermia, to the spread of life, or at least the potential for life. Not through intent, but through motion. Through the same physical processes that form stars and shatter worlds. Through the endless exchange of matter that connects every system to the next. And that brings us back to the bigger picture. 3I/ATLS is one object, one point in time, but it represents something much larger. A sign that the boundaries between systems are not closed, that material moves, that the universe is dynamic, interconnected, fluid. The fact that we saw it, before it passed, before it faded, shows how far we've come. 10 years ago, we didn't even know these objects existed. Now we're imaging them from orbit around another planet. Now we're tracking their chemistry, their motion, their interaction with our star. And with every one that passes, we get better. Better at detection, better at analysis, better at asking the right questions. Because the questions matter more than the answers. What else is out there? How many more coming? What stories do they carry? Are we ready to meet them? And perhaps most importantly, how did we get here? Was our own planet seeded by an object like this? Are we the byproduct of the same galactic processes we're just now beginning to understand? 3I/ATLS won't answer all of that. But it forces us to confront the scale of what's possible. It brings interstellar space to our doorstep and reminds us how small our solar system really is in the context of the galaxy. The universe isn't static. It isn't quiet. It isn't waiting. It's moving. Pieces of it are arriving. And now finally, we can see them. Not as streaks of light or theories in journals, but in high-resolution images, in real-time data, in coordinated international missions launched across planets. This is what exploration looks like. Not just rockets, not just landings, but understanding. And the story of 3I/ATLS is far from over. More data is coming. More analysis. More questions. And the next object, whether in 5 years or 50, will arrive. It will carry different chemistry, a different path, a different story, but the same potential to shift how we understand the cosmos, to expand what we know, to remind us that the universe doesn't just exist out there, it's interacting with us all the time. Stay with this, because the next interstellar object is already on its way. And when it arrives, we'll be watching. If you want to follow that story, every new signal, every new discovery, every next chapter, subscribe now. Because this isn't over. This is just the beginning.